So question 17. A parachutist jumps out of a plane of height h. She is subject to air resistance with force minus alpha v squared. The equation of her motion is given by this equation here. What are the units of A? So the units of A, of alpha, sorry, are going to have to be such that it is a force, it is Newton. So the forces of Newton is this. We know that. Oh wait, my pen stopped working. Okay. We know that this equals minus alpha times v squared, which is going to be meter squared second to the minus 2. So we don't need to account for these. We need to account for one of these. So actually, let's just divide by that. So minus alpha equals kilograms per meter. So that's the units of alpha, kilograms per meter. To calculate the terminal velocity of the parachutist, well, the terminal velocity is when the force is 0. So that's going to be when alpha v squared equals mg, just when this equals 0. So that's when v equals the square root of mg over alpha. So that's the terminal velocity. So now, estimate how much work is done by the air resistance as she falls, assuming that she's falling at near terminal velocity by the time she reaches the ground. So we're going to do this by conservation of energy. So we know at the plane, we have gravitational potential energy equals mgh, kinetic energy equals 0. And then we know at the floor plane, we know that GPE equals 0. And kinetic energy equals a half mv squared. We have v here, so this equals a half m squared g over alpha. So we know that the work done is actually just the difference between these two. So we know that work equals difference. So at first we have this, and then we have this.